Okay, the component form of a vector, right? Like here's a vector PQ. So we're familiar with what that means. It means it's a directed line segment from P to Q. And we just did that when we did the distance formula, we did the x2 minus x1, y2 minus y1. That's what this is right here. You know, if you subtract those, you get what's called a component form, which is the change in x, comma, the change in y. If you're going to call that a vector v, then it'll be v1, comma, v2, the component form of a vector. And the way you know that that is a vector and not an ordered pair is that these are kind of angle brackets there, right? They're not round parentheses, they're angle brackets. That's a vector. Right, so for the vectors that we did on the other page, or on the first example, the component form would have been 3, 2. Right, it's just the change. And the formula then, now they're introducing this magnitude of the length of the vector is written with these double absolute value brackets on either side. And it's a distance formula. If you have the initial and the term points, then it's a distance formula using those. If you have the component form, it's just v1 squared plus v2 squared. Okay, they do, there's, like I said, there's a lot of definitions when you get to a topic right at the beginning. And so here, if the magnitude of a vector equals 1, right, that's right here, then that vector is called a unit vector. Just like the unit circle had a radius of 1, a unit vector has a magnitude of 1, right? And there is a vector which is called the zero vector. And if you see here the vector, the zero vector, and they've got, this is a bold 0, right? And so what it means is the zero vector, and I would write with a little arrow on the top because I can't make it bold, but that would just have both components are 0.